Hi, everybody. So this week we are delving into taking a look at factored form of a quadratic function. So we introduced the idea of a quadratic function last week, and we saw that the standard form was y is equal to ax squared plus bx plus c. And we've explored a little bit what these particular functions will look like in standard form. And today we're focusing on quadratic functions in factored form. So the big advantage to this form is that we can find very easily the root solutions, zeros, and x-intercepts. So this is factored form. There's sometimes a number, a, outside parentheses. If there's nothing written there, it's a 1. And then this is what factored form looks like. So for example, we have y is equal to, and then we've got x minus 1 multiplied by x minus 5. That's factored form. And what's the point of this? Well, we can relate these roots or zeros or x-intercepts to the way that it's written. So x minus the root multiplied by x minus the root. So for example, the roots of this are positive 1, 0, and 5, 0. So written in this way, it's really easy to see what the roots or x-intercepts, we often call them solutions and zeros, they all mainly mean the same thing. We can see from factored form what these roots or zeros are. So let's take a look. What is this equation rewritten in standard form? So this is the same one we just saw. And I think this is really important that we can relate factored form to standard form. So a couple of things here. Recalling multiplying binomials, this is really important. You must remember how to do this for next week's work. So I do want to give an example here. So if you recall, we can write x minus 1 multiplied by x minus 5. We can work this out. This is how we're just going to rewrite it. We're not really doing anything with the graph. So this would be x squared. X multiplied by negative 1 is negative 1x. Negative 5 multiplied by x is negative 5x. This is all review. Negative 5 multiplied by negative 1 is positive 5. And we can put all of that together. So we end up with y is equal to x squared. Negative 5x minus 1x, put that 1 in if it helps you, is minus 6x plus 5. So this is exactly the same as this. These equations are the same. Factored form up here, this tells us what the roots are. This doesn't. Can you spot what it does tell us, though? Have a think. Well, it's positive x squared, so that way we know that it opens up like a smiley face. You may have spotted that this plus 5 shows us where the y-intercept is. So there's different things that you can get from each form, kind of like when we deal with linear functions. You can get, depending on how it's written, you can pull out different information. So factored form is related to the roots and zeros. Okay, let's take a look at this example. It says, consider the equation y is equal to, and then we've got x plus 4 multiplied by x minus 2. It says, find the x-intercepts of this graph. Well, let's take a look. We know that it should be written in the form y is equal to x minus r sub 1, x minus r sub 2. And these are the roots. So with this equation being y is equal to x plus 4, this would be x minus negative 4. And this would just be x minus 2. I do wish I'd put those in a different color, but instead I'll just highlight them. So you must rewrite it, or at the very least think about it as x subtract something. So my roots are going to be, or my x-intercepts are going to be negative 4, 0, and 2, 0. We can verify this by graphing, and at this point you can graph this using Desmos, or you can do a sketch. And I think that's what I'm going to do right now is I'm just going to sketch this. I'm not going to do it in any detail. I am very aware that you guys can use Desmos or your graphing calculators if you wanted to. But you'll find is that this goes through negative 4. So if I just mark this as 1, 2, This is just a sketch, okay? It's not perfect. We know that it's going to go through -4 and +2. And I hate drawing on here, so I'm going to be honest with you. I'm not going to do the vertex. I'm not getting too detailed about this, but I do know that it should go somewhere down here. I don't know what exactly this is going to look like, and I hate that I'm drawing this like this because it's really hard. So sorry. Okay, but there's our sketch. So definitely do this on Desmos. I just wanted to give you a really rough drawing here, and I couldn't incorporate Desmos into the program I'm doing right now. So that's the main gist of what we're doing. I want you just to take a look, though, and take a look at all 4 of these. So you'll notice a couple of things. It says pause here and graph all 4 of these on the same axes using Desmos. So at this point, you should be ready to use Desmos. And it says, what do you notice? So pause right here. So you should have graphed all of these in Desmos, and I don't have all of them graphed in Desmos, but I do have them graphed here. This is the one we started with. We know that the x-intercepts are -4 and +2, and the vertex actually is -1, -9. This was the original one we were given. This looks far better than my previous page. I should have just copied this. Okay, now you are asked to graph y is equal to 2. Parentheses x plus 4x minus 2. What did you notice? Well, hopefully you notice that the intercepts, the x-intercepts are exactly the same, but what's happened to the graph? So it is actually shifted down. It's narrower too. So that 2 has changed the shape of it, even though it still goes through -4 and +2. Now take a look at this one. You'll probably notice right away that it's negative. It's -1. So taking a look at what this would look like, it should be similar to this graph, except, and so it still goes through -4 and +2, but it's the other way around. It's more like a frowny face. And here, finally, we've got -3, the exact same x-intercepts, but it's taller and narrower. So these are the sorts of questions we're going to ask ourselves. How do these things change the graph? So the main points of this week's work are understanding that factored form tells us where the x-intercepts are. We should be able to relate factored form to the standard form of an equation that's quadratic. And we should be beginning to see how these changes in the equation impact what the quadratic function looks like. So a few things, but we're really just introducing this topic this week. We are developing all of these skills. I don't expect you to master everything by the end of this week's work, but we're starting to understand a little bit more about quadratic functions. Thank you.